Hi folks, good morning. I hope you have seen the earlier video exercise 1.3 part 1. Today we will be taking the part 2 of the exercise, that is starting from question number 3, maybe question number 3 and 4 we will be doing in the part 2. So this is the exercise 1.3 part 2 and we are doing the question number 3. Let's see what is there in the question and let's see what they have asked us to find out. They say that express the given in the form P by Q, where P and Q are integers and Q is not equal to 0. They give us a decimal representation and this decimal representation has to be converted into a fraction. That is what the question is all about. So we have to see how we work this out. Basically this entire question, it's a tailor-made format. We follow the format in all the questions, irrespective of whatever digits come, you have to follow the same format and then you are able to get that fraction that is required. So let's see the first question. It says that it is for subpart. It says that it is the number like 0.6 recurring on 6. You should be able to express it in the form of P by Q. So let us see how to proceed. As I said, there is a format of doing this problem. We will proceed with the format and we will see how we are able to do the problem. Whatever is given to us, we will always assume it as x. Let x be 0.6666 as per what they have given us. Having assumed the x, our next step is to check whether the decimal part is only consisting of recurring digits. Yes, that is what is happening. In the decimal part, we have got only the recurring digit 6 happening. So that is confirmed for us. So our next step is to get the digit arranged in such a way that we will be checking how many recurring digits are there in the decimal part. So we have only the 6 recurring, there is only one recurring digit. When there is only one recurring digit, it's a normal step to multiply 10 on both sides. Because it's one recurring digit, we will multiply 10. Had it been 2 recurring digit, we will multiply 100. If there were 3 recurring digit, we would have multiplied 1000. Like that, the multiplication idea will go. Now here, because only 6 is repeating, we are going to multiply 10 on both sides. Let's see what comes up. When we multiply 10 on both sides, multiply 10 on both sides. So what happens is 10 multiplied by x makes it 10x and 10 multiplied by 0.6, the decimal shifts one place to the other side. So it becomes 6.6666 and so on. Having done this, because we have got both the things into the standard form, we give equation numbers to both these equations. We will call this equation as equation number 1 and we will call this equation as equation number 2. And our next step, as I said, it's a tailor-made format. So in the next thing, what we are going to do is we are going to subtract equation 1 from equation 2. That is going to be our next step. What we are going to do? We are going to do 2 minus 1. Equation 2 minus subtracted. We are going to subtract equation 1 from equation 2. And let's see how what works out. So you will have 10x equal to 6.666 that way, and here we have x equal to 0.666 that way. We are subtracting them. So what happens here? Because the decimal parts are all 6 minus 6, 6 minus 6, 6 minus 6 is 0 and so on. It continues everywhere. And 6 minus 0 is 6 over here. 10x minus x, it is 9x. We all know 10x minus x is 9x. In order to get the value of x, the 9 will go on the other side and it will become 6 by 9. So actually our 0.6 recurring is actually 6 by 9. But incidentally here, because 6 and 9, they can be reduced in the table of 3. So it can get reduced to 2 by 3. As a result, our answer now becomes 0.6 recurring on 6 can be expressed as 2 by 3. That's our question. Express it as a fraction in such a way that the numerator and denominator, they are both integers and the denominator is not equal to 0. So this is how we express it in the required form. That is the first problem. As I said, we follow the tailor-made format and that's how we will be getting the answer. Quickly, we will go to the second subpart, and in the second subpart, they give us a question 0.47 but recurring only on 7. It's not so simple as the previous problem. There are 2 digits in the decimal but only 1 digit is recurring. Not both are not recurring, only 7 is recurring. Okay, so as we did before, we are going to start with the x. Whatever is given to us, let's assume it as x. So our x is 0.4777 because it's recurring on 7. Now things are not so easy like this problem, because here the decimal part had only recurring digit 6. We quickly multiplied and so on, we got the equations. But here it's not like that. We like to have an equation with decimal part only recurring. We don't want this kind of a expression where there is recurring and non-recurring digits occurring in the decimal part. We don't like it. So what we will do is we will multiply, we will try to make this 4, let it go on the whole number part, and let the decimal part be made up of only the 7. In order to do this, we are going to multiply both sides by 10. So what will happen, in order to get it into our convenient form, we are multiplying both sides by 10. So what happens, here it becomes 10x, and the 4 goes to the whole number part, and this becomes 777 like that. Now this is in our desired format, because we wanted a format where we should be having only the recurring digit in the decimal part. So we have got it in that format. So we are done with the first part. When we get it in this format where we will have the decimal part made up of recurring digits, we are now allowed to call this equation as equation number 1. Earlier we didn't have it in the desired format, so we couldn't call it as equation 1. We've got it now into the format, and now we are calling it as equation 1. Having got equation 1 as we did here, the very first, the next step that you're going to do is check out for the number of recurring digits. How many digits are recurring? Whether 1 digit is recurring or whether 2 digit is recurring. Depending upon how much digits are recurring, we are going to have the next step. Luckily here for us, like the previous problem, only 1 digit is recurring, that is 7 is recurring. As a result, because only 1 digit is recurring, we will multiply 10 on both sides once again to get the equation 2. So multiply 10 on both sides. So what happens? There is already there is a 10x. 10x into 10 makes it 100. 100x, and here it is 47.777 because you've got this multiplication by 10. So we've got now equation 1 and equation 2 both. As we had done there, as I said, it's a tailor-made format. Our next step is to subtract equation 1 from equation 2. So as a result, we have 100x to be equal to 47.777, and then we have this 10x equal to 4.777. We are subtracting and see what happens. 100x minus 10x, we all know it's 90x. And here we know that it is like you have the this getting subtracted, you have 777 getting subtracted, 47 minus 4 is 43. Like that, your x value becomes 43 by 90, and x which is 0. X which was 0.47 reckoning on 7 can be expressed as 43 by 90, which is our desired format, and this is what is required to be done. So this is what we will be doing. One extra step is coming here because the decimal part was not in the desired format. So that is our second subpart. We will quickly move to the third subpart, where they give us again question which is slightly different but yet very manageable. So let's see how we are able to do the third subpart. In the third subpart, they give us a question like this. They say that it is 0.001. It's recurring on all the 3 digits. So as without wasting any time, since we have now learnt the methodology, so we are going to call this number as x. So let x be 0.001001001. That's the meaning of the recurring that they have put there. We have got this, and we are looking at the decimal part. Decimal part has got only recurring digits, non-recurring digits are not there. So we have it in the required format. That is why we call it as equation number 1. Then we will look out for the number of digits which is recurring in the decimal. So the number of digits which are recurring in the decimal, they are 3, because this 0, 0, 1, 3 digits are recurring. Because 3 digits are recurring, we are going to multiply both sides by 1000. So therefore, in order to get our equation number 2, we will multiply both sides by 1000. And that's how the left hand side becomes 1000x, and the right hand side, because it is multiplied by 1000, becomes 1.001. All this has got shifted, 001, 001, and so on. That's how you get your equation number 2. We have learned it before that we are going to subtract equation 1 from equation 2, and that's how we are going to get our next step. 1000x is equal to 1.001, 001, and so on, and x equal to 0.001, 001, and so on. we're getting it subtracted, and let's see what happens. 1000x minus x, we all know is 999x, and here we have the decimal part all becoming 0, and then you have 1 minus 1 becoming 1, like that x becomes 1 by 999, and since x is our creation, we come back to what is given to us. 0.001 recurring on 1 can always be written as 1 by 999, which is our p by q form, and q is not equal to 0. That is our question number 3 with these subparts. This question is very, very important. Why? Because there are lots of chances that these kind of questions can come in the 10th standard board exam, because there are portions relevant to this even in the 10th standard. Without actually teaching this in the 10th standard. They will not, there's no need to teach it again in the 10th standard, because you know all this already from the 9th standard. So suppose if a question like this comes in the 10th standard, you should be able to attack that problem also by the memory of these things. So from that angle, this becomes important. You have to be having this in the memory. If any chance, by any chance it comes in the 10th standard, you should know to attack these problems by keeping this in the mind. So that is our question number 3 with so many subparts. Now we are quickly going to question number 4, which is also of this type, and it's a tricky and quite a good question and kind of application thinner type problem. Let's see what they say. Express 0.999999 and so on in p by q form. Are you surprised by the answer? With your teacher and classmates, discuss whether the answer makes sense. So they are asking us to express, this is our question number 4, they are asking us to express 0.99999 in p by q form, and they say that you will get an answer which will surprise you, and they are asking us what is the reason of that surprise, and they are asking us to discuss and find out how do you get such an answer. So we will not keep that suspense in mind. Let's right away solve it and see what we are going to get. So as we have learned before, let's call this as x, 0.99999, and we have the decimal part full of recurring digits, so therefore right away we can call this as equation 1, and the decimal part has got only the recurring digit 9, only one digit is recurring, so therefore obviously our next step is to multiply 10 on both sides so that we can get the equation 2. So we are going to multiply 10 on both sides. So what happens? This becomes 10x and this becomes 9.999 and so on. This is how you get the equation 2. Since we have only 9 as a recurring digit, it allows us to multiply 10 and we get the equation number 2. We know our next step is always subtracting 1 from 2. So therefore our next step is we are going to subtract equation 1 from equation 2. Like that you have 10x, which is 9.9999 and so on, and x, which is 0.9999 and so on. We are planning to subtract this. So what will happen? Here we have 10x minus x, which is 9x, and here the decimal parts, they become 0. 9 minus 0 is 9. So 9x equal to 9. X becomes equal to 9 by 9, 1. This is the surprise that they were talking about. So what we are getting, 0.9 recurring on 1, recurring on 9 works out as 1. This is the answer, and that is what they were telling in the question, that the answer will surprise you and you discuss why this answer is coming like this. 0.9 recurring is coming up as 1. Why? Because 0.99999, it's very close to 1. Just visualize that number on the number line. It's very, very close to 1. That is why when we write it in p by q form, it comes as 1. Basically in p by q form, it is 1 by 1, and that is the desired form. So that is about the p by q questions. As I told you, it's very important from the 10th standard point of view also. So always keep it in memory how to solve it. Thank you, and we have a part 3 video also coming up. Thank you.